Welcome back to Advent of Code 2021 to 21, day 22. Reactor reboot. Shorter description. All right. Let me just grab my coffee. All right, so nearing the end. I'll just do one problem today, I think. Even if it's a short one. Operating at these extreme ocean depths has overloaded the submarine's reactor. It needs to be rebooted. The reactor core is made up of a large 3D grid made up entirely of cubes, one cube per integer 3D coordinate. Each cube could either be on or off. At the start of the reboot process, they are all off. This is referring to an old problem. I don't know. Okay. To reboot the reactor, you just need to set all of the cubes to either on or off by following a list of reboot steps. Each step specifies a cuboid and whether to turn all of the cubes in that cuboid on or off. So this is saying for that range, turn them on, off, so on. Okay. So first thoughts are, it's easy for this to blow up. So if you were just to keep track of every individual cube that's on, that could be too much. But then for part one, that might not be. That's 30,000 difference. 1,000. Seems like it could be too much, but we'll try it anyway. Alright, so anything else we need to look out for? It's just the initialization procedure only uses cubes that have XYZ of at least -50 and at most 50. Okay, so we're just looking at the small section first. And then we have to deal with the big ones. All right. Right. So I need to pause this. I suppose we can use regular expressions here. pattern. It's gonna be like be basically, is this how we do it? On or off. X equals, and then we've got int. So it can have a minus sign, and the okay. Is that the pattern? We'll test it in a second. And then so it'll be we don't match pattern line. Should we strip it? Or G and RE dot groups. Just okay. Just print this for now. I want to see. Perfect. Okay. So we can start off with the straightforward approach. We just record a hash map of all the ons. So everything's off by default. So these lights, what are they? They're just cubes. Okay, so cubes equals set. So this is going to be a set of ons. So x1, x2 equals int it's g1, g2. It'll be y1, y2. Z1, Z2. And then we want to just... So I already know what the more efficient approach is, I think. Just basically storing things as subcubes. Maybe we should just do that approach. So you record a cube by its endpoints. And you just say everything in that is on. And then if two cubes overlap, what was the question? How many cubes are on? either we'll just solve this the slow way first. So say for x in range x1 so if G0 is on, we want cubes dot add x, y, z, else cubes dot remove x, y, z. And then finally we just print the size of cubes. Oh, you're not allowed to remove. If it's not in there. I'm not sure why you're not allowed to do that. Like, I would have thought it's a set operation, so you should just remove it if it's there and just not return an error. Okay, fine. Oh, stop. We didn't do the one, so it has to be the ones between 50. Okay. So, oh. If not, let's just say all minus, let's say absolute value of k is less than or equal to 50 for k in G onwards. So just they all if any of them exceeds 50 in any of these dimensions, then skip that one. Oh, damn it. Oh, yeah, okay. Just turn it into an int. Oops. Stop. Okay. Okay, so that's correct. Now that the initialization procedure is complete, you can reboot the reactor. Starting with all cubes off, run all of the reboot steps for all cubes. Okay, so now we just have to do it efficiently. So this, we're not using that anymore. So what do we do? I think, so we can store it. We store it as a bunch of cubes that are on. So okay, cuboids. That are on. So if it said like, 0 to 50, 0 to 50, 0 to 50, then I wouldn't store each individual cube. I would just say store one cuboid with corners 0, 0, 0, 50, 50, 50. Put that in a list and say everything in that is on. Just call it a day. So how do these combine? So if two cubes overlap, we can break the cubes into, so the overlap, so if two cubes overlap, the overlap bit is a cube. We can split the whole space into a bunch of cubes, one of the cubes being the overlap bit, and so if two cubes overlap, we just need to find, so how many cubes are you going to end up with? I think it's like 15. Or we can actually write, if we can write out the for loop, and we should get them all. So we're saying, two cubes overlap, then there's one cube that is the overlap, and then there's like a bunch of cubes which are not. That's what we need, basically. Let me think if there's a cleaner way to do this. I mean, that's not too bad. Alternatively, we can use the inclusion-exclusion principle. We just keep all the cubes. We don't break them into smaller cubes. We just say this bunch of cubes is on, this bunch of cubes is off. And then to find the answer, we have to basically find all the overlaps, but the problem is there could be a lot of how many cubes do we have? 420. So there could be. I think the inclusion-exclusion principle is not a good idea here, because then we'd have to. Let me have a quick think. This is how I'd do it if we were doing squares. So let's just try that then. So instead of cubes, we would say yeah, Yeah, so we're storing only the cubes that are on. So when you add a cube that is on, you basically go through, you have to check it for an intersection with each cube that you already have. And if it does, then you need to split them. Or we just account for like double counting and triple counting and stuff. So we keep the cubes as they are, but we say every time we found an overlap, we add an overlap cube, and we say that cube contributes like -1. So if there's a cube that's on, and there's a cube that's on, they each count 1. But everything that's overlapped will be counted double. So we add one more cube, which is a negative cube, and that's the overlap cube. And that will count for -1. So that means we don't have to keep breaking cubes up. But the overlap is there to... Oh, but I don't know. But then what happens when we overlap with that overlap cube? It gets messy. No, I think we have to do this cube splitting, so... Alright, so, how do we get started with this? We just have to... Okay, so we've got a bunch of cubes which are on. We take that out. Yeah, okay. Say that. So we've got a cube. Alright, so here. So we have to define like an insertion. Alright, let's make this a class. Cube space. So we just have a set of on cubes. We want to define add cube, and it's gonna be like this. So this basically adds an on cube. So we go through each cube that we already have. And if it intersects with this cube, we just have to split it into the cubes. So for cube in. Stuffed up cubes. The property we're trying to maintain here is that they're always disjoint. They never overlap. Cube and stuffed up cubes. The overlap bit. So we'll have to do. Just unpack this. So the overlap section is going to be we don't need to. Right, overlap X equals if the overlap would be like that. Wait, what? So it'd be A1 X2 else overlap is none. If so, it'd have to overlap in all three dimensions to actually properly overlap. So if overlap is none, I mean, we can just say here, else skip this cube. Let me just do the same for the Z. Alright, so hang on, so it's A1. Okay, so that's just right. X overlap. Alright, now we look at Y overlap. Well, so this should really be like config cube, because this we might add or we might remove. So we want is add. So that'll tell us. So first we do all the splitting, then we decide whether we're actually inserting cubes or removing them. Still part one? No, I did. No, part one was really quick. I'm on part two now. B1 between Y1 between B1 and B2. And we want the Z overlap. I don't know if there's a cleaner way of finding overlapping sections between two cubes. And then once we've got that, we then have to split it. I mean, it might not be too hard after we've found the overlap, because everything is just like the section of the cube up to that overlap. So Z overlap is going to be C1, Z, C, Z, C. Okay, so we've found oh, well, it's going to be like overlap X. Okay, so now we've got 3 overlap intervals. So the overlap cube will just be like the cube spanned by those 3 overlap segments. So if we get this far, then there's a proper proper non-zero overlap between these 2 cubes. So that is defined by this overlap cube equals so it'd be overlap x0. So it'd be like this. So it'd be like 0, 1. 1. So that's the overlap cube. All right. And then we basically need to find think the cube splits into 5 cubes. So there's the overlap, which is like part of it. And then... also, at the beginning of this, we should just make sure these are not 0 cubes. Because then we don't do anything. If x1 is x2, or even an invalid cube, well, we shouldn't have those. If x1 equals x2 or y1 equal... Oh, no. It's okay for them to be equal. That's a one-size cube. We don't need anything. Okay, so what have we done so far? So for given each cube that we've already stored, we're splitting it into the overlap. So if we've got this far, that means we're not going to insert this cube as is. Instead, we're going to split it into these 5 different sections and then try to call insert on each of those 5 separately. So basically, if we were to go through this for loop and actually reach the end of it, that means it didn't intersect with any cube. That means it's safe to just add it. So we can just say if is add then we just do self.cubes.add that. And if it wasn't is add, then we don't do anything because it's just empty space. We don't do anything. Okay. So now it remains to figure out what happens if it splits. So if it splits, we've got one overlap cube. This is going to be confusing. So if there's overlap, we must destroy this cube and replace it with a set of smaller cubes. But we can't remove it while we're in the for loop, can we? We're going to break out of the for loop. I don't know if it'll let me remove it. So if we got this far, then we must say cubes.remove. That. Are we allowed to do that? so far we can try inserting it. It'll insert the first cube. It'll insert a bunch of cubes, and then at some point there'll be overlap and they won't add them. Let's just try that. So we want cube space. So it'll be cube space dot config cube, and it'll be x1, x2, y1, to z1, z2, and then finally that. Try running it. It won't work. Set change size during iteration. Okay. So we have to say if we have to do else here. So that only happens if we never broke out of the for loop. If we did broke out, then we would go to this line here. So whatever cube was, that needs to be removed. So self.cubes. So basically that. Try that then. Cannot access this local variable cube where it is not associated with a value. Wait, if we broke out... Hang on, no, it won't go to that line. Yeah, so what... God, this is so confusing. Maybe it's better if... Do we actually want this to be a set? Yeah, no, there's no reason not to have as a set. Or it could be a list. No, a set would be efficient to remove. Problem is... Okay. maybe instead we should just rebuild a new set of cubes every single time, but it's always one where they break down. Alright, so this is actually a list, maybe, instead of a set. We go through that list, and for each cube we're appending to a new list the new cubes, and then we just swap them. Let's try that approach. Do that. And then we go for cube in self.cubes. So we basically got a new set of cubes. Equals that. And then we are just dealing with that. So okay. So if we find overlap, so for cube that's in self.cubes, we're deciding whether it gets added to new cubes or not. So we check if it overlaps in the X. If it doesn't, then we can immediately say it's safe to just add to new cubes. So we say new cubes dot append cube. This does not interfere with our current cube. And then we continue. And then similarly, damn it. There's still some problems with this. I don't know if this is really the right approach. So the cube we're trying to add needs to keep breaking down as well. Oh. There's no reason we can't do that. Alright, maybe this, what we need really is an outer method, which just takes two cubes and turns them into the full set of cubes. That means we don't have to do that logic in here. Alright, let's just do that. Define get overlap cube 1, cube 2. Alright, so given two cubes, we want to find the cube that is the overlap between them. And we want to return three things: the overlap between them, and then cube 1 broken into a bunch of smaller cubes, and cube 2 broken into a bunch of smaller cubes, such that they have one cube in common, which is the overlap. That's what this method is. Yeah, okay. This will be better. So we can say right, and then we say alright, so if overlap x equals that, otherwise overlap equals that, that's fine. And if they don't overlap, then we can return immediately. Just say else. So we don't do that. We just say return none for the overlap. And then these cubes just stay as they are. So return cube 1, cube 2. But it's a list of cubes. Yeah. Do this. Wait, what happened? Oh. Overwrote it. Oh, I see. Okay. I was pasting it in the wrong place, so do that. Alright. So Y overlap, similar, but we get rid of that and just say that. And Z overlap. That. Right. And then finally, if we reach this point, they do overlap. So we say overlap cube is this. And then we want to turn the first cube and the second cube into to break them up. So so we split the first cube. That's going to be it's which corner or what part of it they overlap in. Oh, this is so confusing. Could be a better way of doing this. Maybe recursing on dimensions or something. Hello, Smab UK. We split the first cube, so and the other way of doing this is the inclusion-exclusion principle. Maybe that would actually... I mean, that would be cleaner to write, but the problem with that is there's so many... No, that would be worse, because there's so many intersections and stuff. To pop out to the post office as you start the stream. I'm on 22, so it's a bunch of cubes, big cubes, and their intersections. I mean, I've solved this problem for squares many times before, so I sort of know what the approach normally is. Like, when you have two rectangles that overlap, split it into, like, 4 rectangles, one of them being the overlap and the others not, and then you have non-intersecting rectangles. Now I'm just trying to write it with cubes, which is just way more confusing. In theory, you could just write the rectangle version and just use that in each project. Alright, so if a cube intersects with a cube, we've got the overlapping bit, and then I think it's 1, 2, 3, 4 non-overlapping bits. which are cubes. So, well, not cubes, cuboids even. We shouldn't be calling them cubes. Oh, we've used the term cubes now. So there's the bit which I mean, this could even have 0 size if one fully contains the other. So, split the first cube. What are the... So it's basically a Cartesian product of, but we just want to split the... Oh yeah, okay, so we split the intervals. So the x overlap was this. And we take whatever's left, so it'll be at most 2 tails. There's the overlap bit, and then there's at most 2 separate tails, but there could just be 1. Or none. There could be none. So there's part 2 then? Yeah, I'm doing part 2. It could be 0, 1, or 2 bits to the overlap. So we just make a variable number here. And same for the y, and same for the z. And then when we've got those 3 things, we can just take like the Cartesian product of them, can't we? No, not the Cartesian product, the whatever it's called. Combinations. So there could be 8 possibilities, is that right? Yeah. And then including the overlap, that means if a cube intersects with a cube, that's potentially splits into 9 subcubes, is that correct? I'm trying to visualize a cube in my head now. Yes, yeah, that makes sense. An easier way to think about it is if it's like a Rubik's Cube. Have a Rubik's Cube. Oh my god, that might actually help. Let me find my Rubik's Cube. I forgot how to solve the Rubik's Cube, but anyway. If this is the big cube, and it's intersecting with, let's say, a cube of size 1, so it's just literally just one of these pieces, then let's say that small cube is like at the center cube. So the intersection between the big one and the small one is just that small cube. And this doesn't help. Okay, if we assume like this, the corner cube is the intersection. So we take another Rubik's Cube and this one, and they just happen to intersect on one piece. Then how many cubes does that split into? I guess there's 1, which is the overlap, and then there's like 1, 2. I mean, I think I trust the the code more than trying to visualize it with a cube. So I think it is actually 9. It splits into 9 cubes at most. And it's possible that one of the cubes is just consumed by the other one because it's fully contained, and that will actually work here because we'll get nothing outside the overlap. The overlap will be fully contain one of the intervals, so we'll get an empty list for that one. And then if we try to take the combinations, we get nothing, which is correct. Because that means that cube vanishes, and we just completely replace it with a big cube. And the cube will still split, but it doesn't matter if we split it. Alright, so how do we now do this? So we want to say split first cube based on overlap. So we go back to the first cube, which was this one. So we look at the overlap, which is overlap X. And we say so we're going to say X sections equals just a list, and then we take the X overlap and we look at the interval x1, x2. Say the possible sections are, it's going to be like this. It's going to be x1 to overlap. Let me just mark what we're trying to do here. So we've got x1, x2. That's first cube, and then we've got overlap. I mean, if we can get this right, then it's basically copy and paste for y and z. So 1. So the outer lap essentially is going to be x1 to overlap 0 minus 1. And if that's valid, so if x1 is, what am I trying to say? If x1 is less or equal to that, then that's the section we add. And then similarly, the other section would be overlap 1 plus 1 x2. So if x2 is greater or equal to that, I mean, we can just say less than here, greater than. So this one will be from overlap x1 plus 1 up to x2. So that's the x sections. This is just the first cube, but then we have to do it for the second cube. Well, there's probably a way to save code, but I don't mind pasting this like 6 times. Alright, so that's the x sections. And then we got the y sections, so it would just be the similar y1 overlap y. And then we got the z sections. I don't think I'll have time to finish this today. I mean, I don't know. We've basically done the bulk of the work right there. It's a case of now basically doing that. Okay, so now we've got the Z sections. And now what? We want itertools.combinations or something like that. I need to look this up. No, it's not combination. Wait. There's a million different things in itertools. I always forget which one's which. No. Combinations is one iterable. Are we not? Is this not just? Let's see if Google AI will tell me. Python function range could take one item from each container, generate all possible combinations. Stack Overflow. Of course, it's itertools.product. You're taking the product. The very first thing I said was the correct one. It was Cartesian product. Right, so it's, you can give a bunch of iterables and it'll take one thing from each. So for R in itertools.product of X sections, Y sections, Z sections. what's it gonna look like? So it's just gonna take a list of so each one of these will be an interval. Right, so then the cube that is the combination of these intervals will be let's make sure we're not reusing the word cube. Cube 1, alright, we'll just say T x1, the temp equals min hang on. No. So the temporary cube will be R0 to get the x interval, and then it'll be 0. And then we get the 1. Yeah, okay, this is straightforward. So it'll be 1, 0, 1, R2, 0, R2, 1. That is the replacement for the original cube. Now, it could be, we could, there are possibilities. It could be, that there are no R. There's no valid R's. That means that cube just disappears. It's basically overlapped fully by another cube. It could be that we get all 9 possible combinations. Okay, so we need to just say new cubes. So cube 1 is going to change into new cube 1s. Alright. That gives us the cube 1s, and then we have to do that for cube 2. So literally we just change everything to A's and B's. Yeah, whatever, we'll just copy and paste it. Now we want to split. That's a bit indent. Now we want to split the second cube based on overlap. So X sections again. Then we're doing A. And we use the same overlap because that's the point. It's the overlap. A2. So that's A. All the X's changed to A's. All the Y's changed to B's. the Z's change to C's. And U cube 2's. So for R, protocols, U cube 2, stop and okay. And then finally, we just return those. So what level of indentation are we here? Okay, so return overlap cube, U cube 1's, U cube 2's. That is the split method. Call it split, not split maybe static. Yeah, it is static, isn't it? It's not actually using a using any properties of the instance. Alright, so that's kind of crazy. But the point now is that we don't have to do anything here. We just say get rid of all this. We know how to split two cubes. So what are we doing now? God. So basically, we're inserting this cube. If it doesn't intersect with anything, we can just safely add it. If it does, then for every cube it intersects with, we need to split those cubes. But we also need to keep a track of how this insertion cube is splitting up as well. So we basically rewrite all the cubes that are currently in the cube space to be the split cubes. And then when we get to the end of that, we then say we now run config cube again, but this time with each of the new split cubes, and try to insert those. Yeah. So U cubes. Yeah, okay, so for cube in self.cubes, we check if they split. So overlap U cubes, new config cubes equals let's use this method. So it's cube space dot split. Okay, can we just call this one the config cube? and new, okay, and existing cube. Problem is, when we've done this, config cube splits, and this method is no longer valid. We actually have to recall the method from the start. Okay, we can do that. So basically we say uh, go back to using a set here. So for existing cube in sub.cubes, if it splits, then we have to call this method again, but with the split cubes. Overlap new cubes, new config cubes equals that. If overlap. So if there is overlap, that means this fails and we have to call config cube again. So we want to remove existing cube. So to be removed equals existing cube. And then we've got the new cubes and the new config cubes, so we break out of this. So if to be removed is defined, that means we found something to split. Then self dot cubes dot remove to be removed, and then for cube in new cubes, which we've computed here, self dot cubes, just add it in. So we've split our cube, but we've not actually inserted anything new yet. And then we have to now just call config cube on each. So basically, for C in new config cubes, we just have to call this one separately for each of them, I guess. I'm worried that this is going to become really quadratic. Oh, we'll find out. Config cube is add, so we want to add just C, and the same is add variable. That's the recursion. If to be removed, else we made a full pass. There was nothing that overlapped with this. So it basically we say if it was is add, if, then we just add the cube safely. Config cube gets added. Self.cubes.add config cube. And if it was not is add, that means it's a remove. Nothing happens because it didn't overlap with anything. So, yeah. Is that it? That whole thing? None of this has been tested, and let's try it out. Cubespace.config cube. So we do that. What doesn't it like? Unexpected arguments. Oh, because we want it as a cube. So if that actually works, then this should just be a whole bunch of cubes which are completely disjoint. Wait, but the overlap cube... What are we doing with the overlap cube? Overlap it. That needs to get added as well, but only to the existing cube. So we do this. The overlap is also there. So basically, the cube that's currently stored gets fully broken down into all the parts that make up its whole, including the overlap bit. But the overlap bit gets removed from the config cube. So now config cube splits into a bunch of cubes, excluding the overlap. Does that make sense? Oh wait, no, I'm not sure if it does. No, it depends on whether it's a remove or a... More confusion now. Okay. It depends on whether we're adding it. So if is add, then we add the overlap as a cube. If it's not, then we remove it. And then whatever the new config cubes ignores the overlap because that's dealt with. No, wait. Not. Because it may overlap with other cubes. So we actually have to keep using it. Because the overlap might overlap with other cubes, and so yeah. So we fully split the second cube and the config cube and do config cube with all those parts, including the overlap. But whether we actually keep the overlap as a cube just depends on whether we're adding or removing. So if it's an add, then we keep it. And if it's a remove, we don't. That means each time we overlap with something, we might remove that. Oh, it's confusing. If this actually finishes, then what do we actually want? Let's see if we actually get anything. If, oh, okay. Cube space dot split missing 3 required. Oh yeah, of course. Dot split. Existing cube. Config cube. Missing 1 required positional argument cube 2. We don't still say self, do we? Do we do that? But it's a static method. Ah, we shouldn't have self there. Maximum recursion depth exceeded. Really? Whoa, god, these split a lot, don't they? Oh my god. I'm gonna have to rethink this method. Okay, it might be working fine. But it's, I'm relying on recursion here, and every split is another recursion depth, but we don't really want that, do we? Instead, we want like we can increase it to like 10,000 or something, but it's, I think that'll work. We just need a queue. Okay, don't worry about that. We don't need recursion here. We can actually do this in a full... How do we do this now? We can do this in one full pass. Config cube will just keep splitting. This is the cube we're trying to insert. So instead of... So we just have to... Config cubes equals... Just, to start with, it's just one cube. Right. And then for existing cube in self.cubes... Okay. Oh, I don't really, have to have another think about this. It's, like, there's two approaches. Either we could just focus on splitting the config cube as much as possible and don't touch the existing cubes. Yeah? Maybe that's the way to do this. So we say... Okay, let's try that way. So config cube, that's... We start with just one config cube. Right? And then for C in config cubes, for existing cubes in that, if there's an overlap, it should really just be a set, I suppose. Alright, so here's what we do. Say new config cubes is a new list. And then for C in config cubes, we try and intersect each of those with this. So overlap, new cubes, new config, new C. Alright. If there's overlap, then for new C in new C's, we just add those. To the new config cubes. All right. Because they're each of these is disjoint from each other, we're not going to overlap. So this will just be a new set of disjoints. And then just replace that with that. Do a swap. Okay, so all this does, we're not changing the existing cubes, we're just turning the config cube into a list of completely disjoint config cubes, which are completely broken down by all the existing cubes. Alright. This test actually runs. Shouldn't infinite loop, because we're not really doing anything, are we? There's nothing in self.cubes even, we're not adding anything. We've got no while loops. So that is the first pass. I'm not using that variable. Oh, we didn't add the otherwise just we put C in as is. Is this just too slow? Just doing this, even though we're not. No, but there's nothing there. Oh god. This should be an empty list. I don't know what's happening. Got X in range. Oh! Yeah, why are we doing that? Okay, just doing that. Right, just run it. Okay, it's an empty set. Good. Okay, that's a start. Now the second pass. We now have config cube fully split up. Right. So we can safely put C in config cubes. Existing cubes. So we'll just say new existing cubes equals set, I suppose. So for each of these, we do this again. Now, we know that this won't split anymore. It might overlap, but it won't split. So we say so for each of those new cubes, we must add them to new existing cubes. So for new C and new cubes, add new C. And now overlap we only add if it is add. So if otherwise it's essentially a remove. And then finally self.cubes is replaced with existing cubes with new existing cubes. Is that it? Still an empty set. Okay. Because there was nothing there. Ah. If this C doesn't intersect with anything, hang on. Because of the process above, this is the only time it would ever intersect. So the moment we found the cube it intersects with, we break out, right? And if we get here, and we never found any existing cube it intersects with, then that's basically an add. If is add new existing cubes or add C. Cannot pack non-iterable none-type object. Uh-oh. Existing cube. The existing cube is malformed. God. We've got a none in there. Why do we have a none? Ah. This is in the wrong place. Hang on. So when do we break? We break if... So if there was an overlap, we break, because it's not going to overlap with anything else. It can only overlap with one thing. God, we've actually got something. We've got a bunch of cubes in there. Is that a lot? Not that many. No, that's kind of suspicious. Why are there no... Because we've got lots of small cubes in the center. Why are they... Maybe a lot were removed. Okay. Let's try and solve the 50 case. Oh, okay. We'll just see if that's actually the answer. Result plus equal, so be x2 minus x1 plus 1. Y2 minus y1 plus 1, z2 minus z1. I don't feel so confident. But that big number. I mean, that's the right kind of order of magnitude, I suppose. No, it's too low. Okay. Well, we can try and get this working for the 50 case then. Any a greater equal to strictly absolute value of a is greater than 50 for k in this, basically. Say cube equals that. One two seven two nine six. What's the answer for part 1? 580810. Looks like double. Well, we have some stuff to figure out, I guess. There's got to be a cleaner way of doing this, though. Maybe I'll maybe there's some. Oh, there's probably a meta library in NumPy or something that literally just finds the overlaps. Should be using that if we can find it. I think I don't really want to do any more right now. I think just have to do a bit of research and thinking. But the fact that it runs is a good sign, because this is the level of complexity I think that is right, the correct. We're just getting a wrong answer. Let's just have a look at what this kind of looks like. Config. Oops. And the original config cube, what we ended up splitting it into. Oh, we shouldn't be getting empty lists ever. That's an issue. New config cubes equals that. The C in config cubes. Oh, there shouldn't be a case where we don't add something. Let's see. If overlap, if the new C and new CS. Oh, that's interesting. New CS could be empty. So there's overlap, but it's swallowed by the other one. Oh, okay. We still need to add that cube. Oh no, the problem here is that we're just ignoring the overlap. That's the problem. Else, we just add the original C. That might be the issue. $87277. That was smaller, but it's not correct. Well, at this point, it's not too hard to go step by step and see if it's giving the right thing. So here, it's not. There's no splitting. That makes sense. Here, it is splitting because it seems to intersect with the first cube. Seems to only able to split up into two. No, we got 3 down there. Well, it's doing something. That's... This split method is really... This... So much repetition, but... And next time we'll just have to go through step by step and see where it stops being correct. I mean, it's not... Well, the first cube was... that. So it was 22, 28, minus 12, 37, minus 34, 11. Okay. That was the config cube. And then we try to insert that. Oh, that doesn't look right. Why is it only 2? Why does it split in only 2? Or maybe it fully splits on, like, fully slices the cube into 2. I suppose that's possible, but... Usually it's going to split into, like, 9. Maybe not, I don't know. Ah, wait. No, that's fine. Those ones are disjoint from the config cube. Oh, we know C won't split anymore because we've done all the splitting. So every C should just fully overlap or not, right? There's no... Why do we even have this? Take that out. out. So if it overlaps, then if it's add, okay, this is slightly wrong, I think. So at this point, we've split C so much that it either fully is equal or not to each existing cube. No, that's not right. Hang on. It's either fully contained or not. That's what I meant to say. It's either fully inside existing cube or fully disjoint from it. The moment we find one that it is contained in, if overlap will be true. And then as long as it's an add, okay, so that is valid. We do that. And if it didn't intersect with anything, then we do that. I don't know, it looks okay, but have to run it by hand at some point. 87277. Sure, there must be a cleaner way of doing this whole thing. That's what the cubes look like. Starting to think the better approach might have been to do that thing about the negative cubes. So you just add the cubes as normal, but then you add one negative cube to make up for the... Oh, that might actually work. If you intersect with a negative cube... So cubes actually have values attached to them. So like they have 1, and they have -1 if they're a negative cube. And we basically just add up the values of all the cubes. Oh, that could work. How do I do that? If we do that, then... then I don't think we need to really do all this splitting. We just, when we're inserting a cube, we go through all existing cubes, and for each one, if it intersects, then the overlap has to be a negative to make up for the fact that it gets added twice. Then the original insertion cube just gets added with a value of 1. Yeah, so you add it with a value of 1. Every intersection gets a value of -1. And that's it. That's how you add. Oh, but what about all the negatives? Because you have to deal with the negative cubes as well. So for those, you add a positive. That could actually work. I think I'll do that next time. Stop there then. That means like 3/4 of this code is basically pointless. We don't need all this splitting. We just end up adding cubes with value, and we never have to modify existing cubes. We just keep adding adjustment cubes. So could that make things worse? I don't think so. But I mean, this is basically the inclusion-exclusion principle. It could blow up a bit more. It depends. Alright, I'll think about it. That's it for today. See you next time.